In red is a terminator. Terminators are essential for making ribosomes stop reading through so that your protein coding sequence ends at the end of your protein coding sequence. But you may say, well, why don't we just use a stop codon? And you would be right. We should just be using stop codons, except the stop codon is excellent for getting the ribosome to stop adding amino acids to the chain. So if I draw a ribosome in green, then the stop codon is excellent for making stop adding to the end of the chain. So if I've got a growing chain and we'll say it's making alpha helix, then when it encounters the stop codon, that gets detached from the ribosome. But the issue isn't here. The issue is that the ribosome can then just keep reading through in the absence of a terminator. And if it encounters another start codon, it will start making a new amino acid and a new protein. And that's not very good. A new polypeptide normally actually, because it's not protein that we want. So how do we stop that? Well, if we include a terminator, that means that the ribosome will fall off once it gets a terminator. A terminator is often a secondary structure in the mRNA, which makes a hairpin loop, which means that the ribosome just can't read through it because there's steric hindrance. What does this mean for you as synthetic biologists? Well, on plasmids, on vector plasmids, you will often say that when you have your selectable markers, they have a terminator. Because if you don't have a terminator, and you just have your selectable marker and your promoter, then the ribosome will just read through. And if it reads through sufficiently to get to your insert, then you no longer have controlled expression of your insert. So how do we fix this? Well, the simple way is to add a terminator. And that's usually quite robust. This isn't actually the only thing we do because terminators aren't perfect. So another thing we do is we turn our insert around. So if I make the insert blue, and we say this has gone into the multiple cloning site, then if this is the wrong way around, even if the ribosome manages to read through the terminator, if it gets to the insert, it's not going to transcribe it. It's going to transcribe a nonsense polypeptide. And that's much less bad, usually, to the cell than transcribing your insert. Because if it does your insert, that's going to do something that you're trying to control tightly and no longer be controlled. And if it does a random polypeptide, that will just be a protein stress burden to the cell. And of course, the insert itself should also have a terminator, which prevents read through from that. And what you will find in most empty vectors is that in the multiple cloning site, you might not have a promoter, you might not have a protein coding sequence, but you will almost always have at least a terminator, even in empty vectors. So, stop codons are good, but they're not the whole story.